Good day, folks. We're going to look at the question of working engine power, but this will based on power by the pump, right? A windmill on a farm is used to pump a stationary water there. This is the windmill. It pumps the water there, and it pumps the water to the well. From a point A, which is there, in a well, the water flows and past point B, which is point B, at a speed of 2.1 second. So it was stationary. The water from point A, that means the initial velocity is 0, and the final velocity is 2.1 meter per second, and this is the height or the displacement, right? All right. So the work that has been done here is to take the water from there to there, right? And then it passes that point. But we're going to focus here. We're going to focus here on this height. So the pump is filling the water in this reservoir. Okay, now it says define the term non-conservative force. A non-conservative force is a force in which the work done between 2 points is conserved, right? Is independent. Work done is a work done. Sorry, a non-conservative force is a force in which the work done in a moving object between 2 points is independent to the path taken. So a non-conservative force here, it's the force that it's independent to the path taken. Okay, guys, stick to the exam guide when it comes to that. Now 7.2, it says calculate the maximum power delivered by the windmill, which is the windmill. It delivers the power. If the 87 gram a kilogram water is pumped from the well per minute, so it's very important per minute, which is 1 minute. 1 minute is equal to 60 seconds, right? So what are we going to do in order to get the power? As I've shown you in the introduction to power, guys, from this formula that says power is equal to W over change in T. When it comes to power, this W, we can change it, is there, to be the work done by non-conservative force, which is change in T, which is the work done by non-conservative force is change in EK plus change in EP over change in time. So which is, it's going to be half mv final square minus mv initial square plus mgh final minus mgh initial over change in t. Now let's go back. This is the initial height and this is the final height today, right? So let's substitute now. Our mass of water that is transported from the bottom to the top, the final velocity, it's 2.1 square minus 0. Initially it was 0, and then the mass is 87 times 9.8 times the height final. What is the height today? Is 35. The height initial is 0, and we divide by 60 seconds, and this 87 kg water was pumped per minute. So if you punch that in the calculator, you will get 500,55 watts. That's the power that was delivered by the pump from the bottom of the well to the top there, from point A to point B.